When we're solving a systems of equations with elimination, it's going to be a little bit different than the substitution, where we always had at least one equation with an isolated alone variable, like we had y equals. In this case though, x and y are both all mixed up in the equation, so we can have a different strategy we can use. And when we want to use elimination when it's like this, we want to make sure that the like terms are stacked. So x's are over x's, y's with y's, and regular numbers over the regular numbers, equal mark over equal mark even. Like literally all those like things should be stacked on top. And then we have to do a little bit of thinking. When we do elimination, it's going to look like we are combining the two equations, like we're adding them together. But when we combine the equations, one variable should go to 0, because that's what it means to eliminate a variable, that they add up to 0. So right now, if we combined all of these equations, negative 10, this is positive, so it's going to be like plus 5x, is negative 5x. That doesn't go to 0. 7y minus 3y would be 4y. That doesn't go to 0. So we aren't ready to just combine them. So sometimes what we have to do is multiply one or both of the equations by some number that we get to choose in our brain. And after we're done with the multiplying, one of these needs to go to 0. So I can already kind of see here, 5 times what number can get us to 10? Because we need those numbers to match in order for them to combine to 0. They should be the same number, and if one number is negative and the other number is positive, they'll always go to 0. So think in your brain, what times 5 gets us to a 10? And I'm thinking, oh, 2 times 5. When you think of that number though, that 2 isn't just going to be multiplied to the 5x, which is why I'm going to put this whole thing in parentheses, because that 2 basically needs to be distributed to all 3 items in that entire equation, even though we got the 2 just by thinking of the x's. So 2 times 5x is 10x. 2 times negative 3, if only one number is negative, my answer is negative. 2 times 3 is 6y. And 2 times 13 will give us 26. Now, so I don't get confused, I like to literally just cross out that old one. And so then we have that first equation, which we haven't touched, and then the equation after we did our multiplying. And now if we did it correctly, one of the variables should go to 0 for us. Negative 10x plus 10x is 0. That was the whole point. And now 7y minus 6y is just 1y equals negative 17 plus 26 will give us 9. And it's just a positive 1 with the y, we're just done. Boom. We just successfully solved for y. But you're not done until you solve for both x and y, just like with substitution. So we're going to take our y equals 9 answer and plug it into any of the 3 options up here. It really doesn't matter. So I'm going to take this top one and take wherever y was, I'm going to replace it with my answer of 9. And just like with substitution, I recommend using parentheses. So I wrote that entire equation identical, but instead of y, I use parentheses. So now I can take my y equals 9 and put it there to solve instead. So right here, 7 times 9 will give us 63 equals negative 17. And now we need to solve for both sides. Solve for x. So we have this closer negative 10. We always save the close number for the end. And the farther away 63. We'll do the opposite by subtracting 63 from each side. So we'll end up with negative 10x is equal to negative 80. When you start with a negative and keep going down negative, it becomes a bigger negative number. And then since there's nothing in between the number and the letter, this stands for multiplication. So division will be our inverse operation to get x alone. A negative divided by a negative knocks it out, so we're going to get a positive answer. 80 divided by 10 is 8. And we always put our final answer as x comma y. So x comma y. And there's your final answer for that first one.